This video is going to cover the 6.3a lesson on area of a circle. This is page 3, number 7. The area of two objects is given. Calculate the radius of each object's surface to the nearest whole number. So the first one, we have this smiley face, and it gives us the area. We're going backwards and we're trying to find the radius. And for a majority of the problems in this lesson, we're using area equals pi r squared. So for the smiley face, we know then that the area is 3.14, and we're trying to solve for r. In this one, since we're going to be solving for r, we're going to approximate pi to be 3.14. Next, we're going to try to isolate what r is. We're going to try to isolate our variable so that we can start to figure out what r should be. So we're looking for a number that when times by itself equals 1. So that would mean that the radius is 1 inch. Do a similar thing for this stained glass window. It tells us that the area is 50.24. Since they have a decimal there, we're going to use the 3.14 approximation for pi. We'll use our inverse operation. You can either do like in the last one and multiply by the multiplicative inverse or the reciprocal. Or if your teacher's okay with you dividing, like I'm doing, we end up getting that r squared equals, and 50.24 divided by 3.14 is 16. And so we're looking for a number that when times by itself equals 16. And that is 4. 4 times 4 is 16. So we've got an answer of about 4 inches. Number 8, a circular pond 12 meters in diameter, to underline some of these keywords, is surrounded by a brick walk 3 meters wide. Find the area of the pond and the area of the walk, round to the nearest whole number, and sketch a picture. So we've got our pond, and then we have a walk that goes around it. And the first thing is they set a trap for us. It says diameter. And we know that if we're calculating area, we need the radius. So the radius of the pond is 6. So let's start by finding, it actually even asks for the area of the pond. And let's go ahead and round that. It does ask us to round to the nearest hundredth. And whatever your teachers prefer, if your teacher prefers you to use the pi button or the 3.14 approximation, we might get slightly different answers. I'm going to type this out on my calculator. I'm going to use the pi button. I'm going to round to the nearest hundredth, which means that that 9 is going to go up to a 10 because of the 7. And so I end up getting the area is approximately 113.10 meters squared. There's my first answer. Next, they want me to find the area of the walk. And so I know that this, it tells me, is 3. And so that tells me that also this whole larger circle has a radius of 9. And so we'll start with that, which is, let's find the area of the largest circle in the diagram, which is 81 pi meters squared. And then it says we want to find the walk. The walk would be sort of like this border. And so this inner circle, I need to remove it from the largest circle to get this donut shape. And so what we're going to do is we're going to take 81 pi, or whatever that's approximately equal to, could have already rounded it, and take away from it 36 pi to get our final answer. So 36 pi came from here. You could also use 113.10 if you'd prefer. Okay, and so I've got 81 pi minus 36 pi, or you could use the previous rounded answer, rounding to the nearest hundredth, which means we're looking at this 1, so we'll keep it at 37. So we'll say our second answer for the brick walk is 141.37 meters squared. There were two answers that they were asking for. We'll do a similar thing in number 9. Find the area of the machined piece shown, which is made of cutting a small semicircle out of a large semicircle. The radius of the larger is twice the radius of the smaller. So this is the radius of the larger, which means that the radius of the smaller must be half of 10.5. So this would be 5.25 centimeters. We want to find the area of the shaded region or shaded portion. So let's start with the area of the big one. And you might already notice that I need to do something in just a second in order to take into account what's going on in the diagram. 10.5 squared is 110.25 pi centimeters squared. Okay, and what I need to do is I only want, it's a semicircle, it's a half circle. So I'm going to do 110.25 pi multiplied by a half, and I'm going to round that to the nearest tenth. So that's going to give me essentially what this whole thing is, and then I'm going to work out what it is for the smaller one. Okay, and so 110.25 times pi times 0.5 is, rounded to the nearest tenth, 173.2. Let's do the same thing for this radius in this smaller circle. And we still have a little more work to do after that. So this would be area equals the same formula we've been using, pi r squared. .25 squared is 27.5625 pi centimeters squared. We'll take that and we'll cut it in half, so 27.5625 pi times 1/2. Rounded to the nearest tenth is 43.3. And finally, we are now going to take these and we will subtract them. So we have 173.2 minus 43.3 equals 129.9 centimeters squared. Last question on this page. We have a graph with a point lying at 3, 0, which is on the x-axis to the right 3 units. We have a circle that also has its center at the origin, and so we're talking about a diagram similar to this, where this is the radius, which is 3 units. It's actually a pretty simple problem then. We have an area of 9 pi, and I don't see any units, so I'll say units squared, and that is rounded to the nearest hundredth now, 28.27.